Welcome back. Advent of Code 2015, day 16. Our trees coming together. Let's see what we get today. Aunt Sue. Your Aunt Sue has given you a wonderful gift and you'd like to send her a thank you card. However, there's a small problem. She signed it from Aunt Sue. You have 500 aunts named Sue. So to avoid sending the card to the wrong person, you need to figure out which Aunt Sue, which you conveniently numbered 1 to 500 for sanity, gave you the gift. You open the present and, as luck would have it, good old Aunt Sue got you a My First Crime Scene Analysis machine. Just what you wanted or needed, as the case may be. The My First Crime Scene Analysis machine, MFC-SAM for short, can detect a few specific compounds in a given sample, as well as how many distinct kinds of compounds there are. According to the instruction, these are what MFC-SAM can detect: children by human DNA age analysis, cats, several seemingly random breeds of dog, Samoyeds, Pomeranians, Akitas, Wislas, goldfish, trees, cars, perfumes. In fact, many of your Aunt Sue's have many of these. Many of your Aunts Sue have many of these. You put the wrapping from the gift into the MFC-SAM. It beeps inquisitively at you a few times and then prints out the message: children 3, cat 7, and so on. You make a list of the things you can remember about each Aunt Sue. Things missing from your list aren't 0. You simply don't remember the value. What's the number of the Aunt Sue that got you the gift? So let's look here. We have 500 Sues. Okay. With some kind of data in there. So we will pass all the Aunt Sues and then compare it to the expected Aunt Sue. Aunts equal raw dot for each line. Map each line to a Sue. Sue has these things. So we can just do a data class or just a map. I can just be lazy maybe. Split the line, get the number. Do we need the number? I think they're just ordered, so we can just pop them into a list. And then we have goldfish, cars, and Samoyeds. So we have 2. Well, first we want to probably remove all these colons. Then we have 2, 3, 4, 5, and so on. 2 is the so we have to kind of map. String to int add there a3.int, and then we have 4 and 6, 5 and 5, 7, and then M is what we're mapping, so I have a list of maps. Let's see if this worked. Once, print line. muted myself for a while. So let's explain again. Basically, we parsed each line, and we were lucky that each line has 3 things, because I only passed 3. So each Sue has 3 properties, and then aunt Sue has all of them, and then so we go through all of the aunts, check if all of the 3 properties that they have match with all of the property values of aunt Sue. Then we print the number, and then we get 40, which is the one that matches all their 3 elements into aunt Sue's list of properties. So that's how we, yeah, it could be multiple, but turned out to just be 1. And we were lucky that it's always just 3 for each Sue. And we print I, which is the index plus 1 of the aunt in the list, because our list starts at 0 and Sue starts at 1, so, or this input starts at 1, so we need to adjust by 1. And then we get number 40, so we can move to part 2. As you're about to send a thank you note, something in the MFC SAM's instructions catches your eye. Apparently it has an outdated retro encabulator. Wow, crazy. So the output from some of the machines isn't exact values. Some of them indicate ranges. In particular, the cats and trees readings indicate that they are greater than that many due to the unpredictable nuclear decay of cat dander and tree pollen. While the pomeranians and goldfish readings indicate that there are fewer than due to the modal interaction of magnetoreluctance. So what's a real Sue? So cats and trees. We actually want aunt Sue to have more than aunts. So when it is in list of cats and trees, or maybe we can do when this, or maybe when it in, then we have in list of pomeranians and goldfish. Then we have else. And else is what we have here. And then we have a different symbol here. So R and Sue should have more. While the Pomeranian goldfish, fewer than that many due to the module interaction. So there's fewer Pomeranians left than goldfish, but more cats and trees. So Aunt Sue has fewer than the aunt. Actually, it must have more, right? This is the aunt we remember. And then the aunt from the input is the real value. So the real Aunt Sue has less Pomeranians than the Aunt Sue that we remember. Oh no, we remember the list with only a few things. Yeah. So this is what we remember, the list, and this is the actual value from this thing. So the actual value should be smaller. here the actual value should be greater. I think we can assume that it is in the list because the key is checked here, so it has to be in this list and it's always in this list. And then we just need a little arrow here and see what happens. I forgot to return this. I removed this. Aha. Lots of options. That's not good. What is the number of the real answer? That's interesting. Did I do it wrong anyway now? Let's try the other way. Maybe that's unique. Ah, that's a unique one. So the ant from my memory has more cats than the answer from this list. Doesn't make sense, but let's see if it's correct. Correct. Okay, let's think about it a second again. So the ants that I have in this list are the ones that I have this memory about. So I remember that ant 241 has 2 cars, 1 Pomeranian and 2 Samoyeds. And the actual Ansu has 2 Samoyeds, 3 Pomeranians, and still 2 cars. So Pomeranians are growing. That's mad. So we have to check if Ansu has more than Ant in my memory, Pomeranians. Because the output of the machine is an exact value. So the output of the machine was this. Fewer than that. Ah, okay. Yeah. Output of machine, fewer than the output of the machine, fewer than 3. So we have to check for this ant which has 1. Okay, that makes sense. That's it for today. Thanks everyone. See you tomorrow.